Hello, this is Ian Leiter, Network Engineer at ATSU University, and today in this session we'll talk about the ITS Network Infrastructure Group, and we'll cover some of our day-to-day operations as well as some of the fundamental technologies we provide. The Network Infrastructure Group is a subdivision of the Network Services Group in the ITS department here at ATSU. Our team is comprised of 3 people: Kevin Lee in the Arizona campus, Tom Bowles here in our Missouri campus, and myself here on the Missouri campus as well. We handle a wide range of responsibilities, and we are responsible for network monitoring, the ATSU network and internet connections. We maintain the network day to day, apply software updates, patches, address security issues. We also provide escalation support for the ITS help desk and other departments within ATSU. We spend a lot of time on projects, new sites, capacity increase, growing the connection sizes for our internet connections, our links that connect our different sites together. We replace outdated equipment, we upgrade. We work a lot with a lot of different vendors in the IT space. If you think about the network and that terminology, really talking about something that supports and makes the internet and a lot of modern communications capabilities possible. At some point throughout the day, if you think about how many of your applications, devices are dependent upon the network, whether you're sending a text message or emailing or a financial transaction, all those things now are being done through an electronic, some kind of an electronic device, whether it's your phone, your computer, tablet, and all of those things are dependent upon networks. So our main focus in our group is to keep these communications running smoothly, efficiently, and securely. So in this diagram, we'll kind of talk about the role of the network infrastructure, where we fit into the whole bigger picture, and then where some of the other groups fit in within ITS and how each layer is dependent upon another. So here at the bottom of the stack we have the power grid, and really everything that we're doing here is electronic with computers. So at some point or another we're going to be dependent upon power, whether it's a battery in your cell phone or, in our case, the power grid from Ameren UE and the various power providers that we have at all of our different locations. So we have, in some cases, multiple power feeds coming in to our different buildings. And then on top of that, we also, for our data centers, we have generator power backup. So if we have a bad storm or a power outage, we can still provide our services to our users. Then on top of that, we have in our data centers and in a lot of our other wiring closets, we have battery backup units, and those will allow you to still make a phone call or something like that if we have a power outage. Now the next portion of this is the network infrastructure, and that's really where we spend as a network infrastructure group the vast majority of our time. Sometimes it will extend to some of the other layers here, but most of the time we're spent with the devices and the cabling infrastructure that makes this communication possible. So above that, typically if you think about the applications that you use day in and day out, those run on server hardware, and that server hardware is in most cases in our data center in either Missouri or Arizona. And it is pretty much just a souped up computer system that can run lots of applications on it, but not a whole lot different in basic functionality than the PC that you would have at your desk. So the next layer up is what we would call the hypervisor layer. We do at ATSU run a technology called server virtualization. And the company we use for that is it's VMware, and that application allows us to run many servers, virtual servers, on one single physical piece of hardware. So if you were to think about it on your workstation level, this would be a situation where you would have a workstation that's running many copies of Windows all at the same time and sharing the resources of that PC. This is what's happening on the server level, and it provides many benefits. Cost-wise, reliability, a lot of different things, a lot of different reasons we run virtual servers. So the next level is the operating system, and we're talking about the Windows operating system. In most cases, we have some Linux as well, but the majority of our servers that host the applications are Windows Server operating system. Then at the top layer, we have the applications, and this is probably the point where the most people will have the greatest amount of familiarity with these systems. Campus View, Citrix, Great Plains, web pages. Those are all run as applications on top of an operating system, which is running on top of a hypervisor, which is running on some server hardware, which is connected to a network. And that's again is the network infrastructure layer, and that's the layer we'll be dealing with in more detail today. So some of the things that I'd like to bring out here are basic terminology, basic networking terminology. We'll talk about IP addressing, just kind of briefly go through some of the different device types that we manage. Talk about redundancy and high availability, wireless networking, wired networking, and wide area networks. IP addressing is kind of one of the most fundamental aspects of communication. If you're trying to communicate with someone, you have to know how to reach them. And that happens over an IP addressing or an IP-based network in most networks today. So you have an IP address, the person you're trying to communicate with has an IP address, and that is what allows you to transfer and share information. It's similar to the way that a postal code would allow you to reach someone in another city, communicate with them. So now we're talking about switches, and that's what on a local area network, like we have here on, let's say, the Missouri campus or the Arizona campus, if we have a computer that's in one part of the building and a computer that's in another part of the building, and those two want to share information on the local level, that would be an application where you would need a switch, a network switch, to connect those computers together. And so you can see kind of in the picture here, this computer's in the CITC building. This other computers in the CITC building, they're connected to a common switch, and that allows them to transfer information and communicate. I've also included a picture of a small home office switch here on the left-hand side, and this would be like something that you'd be used to seeing in your house. You know, not too big, connect 8 devices together. That's kind of the size of a typical, you know, small home office network. But then on the right-hand side, these are kind of the standard switches that we use here at ATSU, and they have obviously a lot more capacity, a lot more ports, a lot more capability, and we'll kind of go into detail some of what those capabilities are a little later on. So a network router. Router is a device that allows you to communicate to people in different networks. So one example would be, in our scenario, is we have another campus in Arizona and another campus in Kirksville, Missouri, and several other sites. We've got a new site in St. Louis. These routers are what allows these different networks to communicate together. And you can see here you've got a group of computers in Mesa, a group of computers in Kirksville. And the routers are what ties these networks together and allows them to communicate. And a lot of the security mechanisms are in place, such as encryption. It's what allows us to communicate over even public networks in a secure manner and keep that communication private. One of the main aspects of networking is, the main concepts is high availability, and we achieve that through redundancy in general. And I like to use the analogy of the airline industry, or an airplane. If you have an engine failure, the airplane can still land safely because there are two engines. And this plays out in a lot of different areas, and a lot of different industries, and the IT industry is a prime example of that. Back to that whole diagram that we had with all the different layers of IT services. You have the server layer, the hypervisor layer, the operating system, and then the applications. If the network fails, every one of those layers will have a problem. And so one of our main goals here in our group is that we want to design and maintain systems and networks that are as redundant as we can make them, and as reliable as we can make them. And some of the examples that we would have in our own network here are dual power supply inputs. You know, if we have a power supply failure or a problem with a particular switch or router, then we have two of those units, and so we can recover or maintain service even if a single unit has failed. And this just translates to a much more productive university, and we're able to, in many cases, and we've had this happen many times, where we were able to recover from a serious outage because we had implemented the systems in a redundant fashion. We're able to repair that and get it back up and redundant and working without any impact to our users. Wireless networks are currently, at least for ATSU and really for the industry as a whole, wireless is really the fastest changing portion of the network industry. Before, we used to always have to plug in. Now you look at an iPad or something like a more modern device that it doesn't even have a wired network connection on it. And it's convenient. It's becoming much faster. It's an amazing technology that I think is still, we have yet to see the end of it. It's changing and evolving quickly. And we have, let's see, in a large building with 2 floors, we would generally require 30 of the units that you see on the right side of the screen. 30 of those units could provide that building with a large amount of coverage and speed to support the number of devices that we have. We have classrooms on our ATSU network in many different locations that have enough wireless capacity to easily serve 400 devices in a single room. And the ATSU network as a whole is supporting well over 2,500 devices simultaneously at any given time, and many of those will join for a while. They'll move to one area. It's amazing to see the amount of activity and wireless data that's transmitted on our network. As of today, we calculate 3.5 devices per student as normal, and that would include, a phone that's wirelessly connected to our network, a laptop, an iPad, and in many cases an additional device. So before, when we used to plan for wireless capacity for a given room, let's say they were going to do an exam or something, or a lecture, we would need to look at that room. Okay, how many people will be in this room? How many students? And if they said 30, okay, that means we've got 30 devices that we need to account for. So nowadays, it's well upwards of 90 that we plan for, because in many cases we even see some students that have 4 and 5 devices that they connect and that they're moving between all the time. The wired network. So I'd like to take a minute to just kind of walk through in our wired network some of the process that you'd go through for even some of the basic operations, like just going to google.com. So the first step is, here on your PC, you would open your browser and go to www.google.com. And the second thing that happens is your computer would begin to communicate with Google by sending a data request from your PC through a series of wires. And one of those wires that you're probably all familiar with is a yellow jack that would connect, or a yellow cable rather, that would connect your PC to a network jack that's in the wall. And from the back of that network jack goes to a patch panel, and that's a network patch panel at some point in your building. And from the back of that patch panel, we go to an access switch. And that's another device that's in your building. This is a data switch that we talked about earlier, a network switch. This network switch is then connected through a couple of fiber optics to a pair of core switches that is in our data center. From there, this request would go to a firewall or a pair of firewalls and go out through one of our internet service providers. And at that point, it's on the internet, and it may go through many different cities before it finally gets to Google servers somewhere on the Google network. And then Google would process your request and reply with the information that you requested. So there's a lot of different pieces and connections that come into play here just to view a simple web page. And this type of transaction is happening millions of times on thousands of different computers in the ATSU network. And this process is really not that different from what happens wirelessly. The only thing here that would change is that instead of having a cable that goes to your network jack, you would have a wireless interface card in your computer, and that would attach to a wireless access point that's connected to this patch panel. And then the process would continue just the same. So a lot of things that we have to consider if there are problems, a lot of different points to check, and that's part of what keeps us busy, trying to maintain that. And then you couple that with security, and there's just a lot of different things, and different challenges and things that we deal with on a day-to-day basis. Another important concept to understand is that ATSU is a wide area network. We have multiple sites. We have many different sites that we connect to and that we interact with. And the bigger picture is that we need to be able to enable private, secure communications between all of these different sites. And this is a great benefit for ATSU, but it can present a logistics challenge. For example, we might have a storm and a piece of equipment gets hit by lightning in our South Carolina Community Health Center that SOMA has. And we would need to troubleshoot that router or wireless equipment and figure out what's wrong, and then either send replacement equipment or try and fix whatever problem it is. And we do all of that remotely today, so we rely on a lot of different people to make that happen, different vendors. And there's just a lot going on behind the scenes each and every day. This is a diagram that kind of depicts the different sites that we have, the basics of how they're connected, and then the fact that each one of those can intercommunicate with the other. Here's a site or a diagram that shows how all the sites are located geographically. This is changing frequently. Again, we've added a new site, St. Louis, that's not here on the map yet, and I think we're adding another SOMA CHC site in Chicago coming soon. And so we're always busy with the projects to bring the network infrastructure into place so that we can meet the business needs of the university. ATSU's national network infrastructure, everything that we've got 2 campus headquarters locations, and I think it's 13 community health center sites, quite a few other sites. And then we've got some specs here that just kind of talks through some of the numbers that we have. Over 6,000 wired network switch ports. I think as things continue to move forward with wireless, you'll see that number drop in the future and the number of wireless devices increase. but still lots of wired connectivity. Let's see here. Lots of firewalls. That's very important as far as the security aspects go, and just a lot more than just one site and one particular building. Everything's interconnected, and this kind of shows the quantities of systems that we have. So to sum things up with all of our networks, this diagram kind of gives you an overview feel for the bigger picture of the total numbers of networks that we have. And I think there may be a few sites that are still missing from this, but this is pretty close. We have a lot of networks and a lot of things that we have to maintain, and a lot of cool challenges that we get to work with here at ATSU. So hopefully this has been helpful to give you a feel for kind of the magnitude, some of the different day-to-day operations, and the things that our team does here at ATSU in the network infrastructure group. Thank you.